Good morning, students. Today we will study about light. Light is something that makes everything visible to us. Light is a form of energy that causes sensation of vision in us. During the day, sunlight helps us to see objects around us. Sun is the main source of light. During the night, we can see the objects because of the light given by bulbs and tube lights. There are two types of sources of light. First is the natural source, for example, sun. Second is artificial source, for example, bulb. Now, on the basis of the light, we are categorizing the objects as two types: luminous objects and non-luminous objects. Objects such as candle, sun, bulb, and tube light, which emit their own light, are called luminous objects, whereas objects such as moon, chair, table, ball, paper, which do not emit their own light, are called non-luminous objects. Non-luminous objects become visible only when they reflect light produced by a luminous object. This reflected light, when received by our eyes, enable us to see the non-luminous objects. Moon is non-luminous. Why? Because it reflects the light of sun on earth, and as we know, sun is the natural source of light, that it is a luminous object. The light reflected by sun reaches the earth as it is reflected by moon, so moon is non-luminous source of light. Now, here arises a question: can a non-luminous object be made luminous? Yes, a non-luminous object can be made luminous by heating it. If we take an iron wire, iron rod, or anything made up of iron, we heat it on gas flame for about 2 to 3 minutes. After 2 minutes, you will observe that the iron wire will become red hot and start emitting light. At this moment, the temperature of iron is between 600 degrees Celsius to 800 degrees Celsius. Thus, some non-luminous objects can be converted into luminous objects by heating them to a certain temperature. Now, let us come to three types of objects: transparent, translucent, and opaque objects. Transparent objects are those objects through which light can pass completely. Translucent objects are those objects through which only a part of light is transmitted and rest part is absorbed or scattered. Whereas the opaque objects, in these objects light do not pass through the object, it is either reflected, absorbed by the object.
But the objects are seen when light falls on them. The object through which light can pass partially is called translucent objects. For example, butter paper and frost glass. The object through which light can pass is called transparent object. It can be seen clearly through a transparent object. Air and different gases are transparent as light passes through them. The object through which light cannot pass is called opaque object. It cannot be seen through an opaque object. For example,
now let us study certain important properties of light. The very first property is rectilinear propagation of light. It states that the light travels in a straight line. Light travels in a straight line unless it encounters any object which changes its direction. The given figure represents a source of light from which the light rays travel through two holes in a straight direction. The second property we have to study is reflection of light. The bouncing back of rays of light as they strike a smooth surface is known as reflection of light. Examples of smooth surfaces are plane mirror and spherical mirrors that we use in our everyday lives. Here we can see the reflection of light by moon on earth.
To show that light moves in a straight line. Things required: 3 pieces of cardboard, a candle, a matchbox, a ruler, a screwdriver. Procedure: take the pieces of cardboard and make holes on each of them with a screwdriver. Make sure that the holes are at equal distance from the center of each cardboard. For this, use the ruler to measure the distance between the holes and the centers of the pieces of cardboard. Arrange the pieces of the cardboard in such a way as their holes fall in a straight line. Put a burning candle behind the pieces of the cardboard as shown in the animation. Observe the candle from the hole of the piece of cardboard placed at the other side. Is the candle visible? Yes, you can see candle in this position. Now, move one of the pieces of the cardboard to a side and again look through the same hole. Now, you cannot see the candle. This activity shows that light moves in a straight line. That's why we cannot see the candle after moving one of the pieces of the cardboard to a side.
Action is: in a dark empty room, from the left, shine a flashlight on a mirror. In this case, you will see a bright patch of light on the wall to your right. This means that when light falls onto a mirror, its direction changes. Such a change in direction of light is called reflection.
Shadow. Shadow formation is one of the applications of rectilinear propagation of light. When an opaque object is placed in the path of light, the rays of light are blocked and prevented from going behind the opaque object. Thus, a dark patch is formed behind the object on a surface such as wall. This dark patch formed behind an opaque object when it is placed in the path of light is called a shadow. An opaque object casts a dark shadow. A translucent object casts a faint shadow. A transparent object casts no shadow. The position of object will always be between the source of light and the shadow. Shadow formation is a common phenomenon occurring in our daily life. You can see your shadow when you walk in the sun. It moves along with you. Shadows are always formed on the ground in a direction opposite to the direction of sun. But as the direction of sunlight changes from morning to evening, the size of shadow changes and the direction of shadow also changes its position. Longer shadows are formed in the morning and evening, and the shadow is shortest at noon. Shadow formation is a direct consequence of rectilinear propagation of light. Now let us study certain necessary conditions for the formation of a shadow. A shadow will be formed only if there is a source of light, an opaque object to obstruct the path of light, a screen to receive the shadow, as shadow cannot be formed in air.
It's a bright sunny day, and there you see an iron rod which has been placed vertically in an open area. Now look at this carefully. You see the shadow cast by the rod on the ground? What happens after some time when the position of the sun changes and the sun now is directly above the rod? Gradually the shadow disappears. You can see that? Great. So let's talk about shadows in some more detail. Look at this tree. You know, this tree does not allow light rays to pass through it. So it's an opaque object. And this region that you see, which is completely cut off from light, is called the shadow. Right? Now the formation of shadows shows that light rays travel in a straight line. And you know something? A point source, a source of light which is small as a point, it forms a shadow that is completely devoid of light. Let's discuss it in some detail. Look at this setup. There is a bulb, and there is a cardboard with a small hole, and there is a pencil. And here you have the screen. Now, why do you think we have a small hole? See, if you compare the bulb with the pencil, bulb is pretty big. I mean, you can't call it a point source. So we allow the light to pass through the hole so that it acts as a point source. Fine. Now what happens? The pencil does not allow the light rays to pass through it. And as a result, a shadow is formed on the screen. You see that? This is the shadow. That is the region on the screen that does not receive light. And this is the region on the screen that receives light.
A shadow is formed when the path of light is blocked by an opaque object. A shadow is always formed in the opposite direction of light.
Now let us study about certain natural shadows. These are also known as eclipse. The word eclipse means to hide. We know that the sun is natural source of light on earth, but the earth and moon are not natural source. The earth revolves around the sun and the moon revolves around the earth. During the course of their movement, the sun, the earth and the moon comes in same straight line in the same plane. When this happens, either the earth casts its shadow or the moon casts its shadow. The shadow cast by the earth and the moon are called eclipse. Thus, eclipses are also known as formation of shadow in nature. Now, depending upon the position of sun, moon and the earth, eclipses are of two types, solar eclipse and lunar eclipse. First of all, let us learn something about solar eclipse. A solar eclipse occurs when the sun, the moon and the earth are in straight line and the moon lies between the sun and the earth. In a solar eclipse, the moon casts its shadow on earth. As moon is much smaller than earth, it casts only a part of its shadow on a limited region on earth. When this happens, either a part or the whole of sun is not visible on those regions of the earth. Next comes is lunar eclipse. A lunar eclipse occurs when the sun, the earth and the moon comes in same straight line. Here the earth comes between the sun and the moon. In lunar eclipse, the earth's shadow falls on moon. Thus, a part or whole of the moon is not visible on some parts or whole of the earth.
Eclipse. When the moon comes directly between the sun and the earth, the moon blocks the sunlight from reaching the earth and casts a shadow on the earth. This is known as the solar eclipse. Solar eclipse occurs on a new moon day. Let us perform an activity to show how a solar eclipse occurs. Take a powerful lamp and place it on a table. Take a basketball and place it on a stand as shown on the screen. Tie a tennis ball in between the stand with basketball and the table lamp. The table lamp represents the sun, the basketball represents the earth, and the tennis ball represents the moon. Light the lamp. You will observe that the tennis ball casts its shadow on the basketball, just like the moon casts its shadow on the earth. When the earth comes directly between the sun and the moon, it blocks the sunlight from reaching the moon and casts a shadow on the moon. This is known as the lunar eclipse. A lunar eclipse occurs on a full moon day. Let us perform an activity to show how a lunar eclipse occurs. Take a powerful lamp and place it on a table. Take a basketball and place it on a stand as shown on the screen. Tie a tennis ball behind the stand with basketball and the table lamp. The table lamp represents the sun, the basketball represents the earth, and the tennis ball represents the moon. Light the lamp. You will observe that the basketball casts its shadow on the tennis ball, just like the earth casts